can automatically tweet out when I'm streaming. Come along for the ride. Let's go to the studio. Here we are. Let's just get rid of boom audio altogether. Quit. Okay, we're listening to the dulcet sounds of Shingo Nakamura. Stream Deck. So if I go configure Stream Deck, I'm asking a lot from my machine right now because I've actually got audio hijack and loopback running with kind of a complex sound setup. I wonder if there's anything I can close that might make it faster. Let's try closing a few things, see if that speeds things up. So I'll close Slack. Come on. Get out of Slack. Close this. I have another Google Chrome session open somewhere. The one I'm looking at. Where's the other one gone? Home. Window. A bunch of them open. Oh, I got IBM Garage open in 2 of them. Let's just close others, close other tabs. Leave the site, yes. Down the bottom. Maybe some of these that I have open, these code windows. Okay, Stream Deck. Configure Stream Deck. I'm gonna add Twitter. Tweet. Live. Only repost this. Yeah. Make sure I've got my fingers in the right place on the keyboard. Text. So, streaming live. Now on live on at Twitch in it, and I'll put a link to my Twitch. Actually have a button for that. Forms. Twitch. Opens my channel. Which means I can just copy the... Oh, takes me to Twitch TV. Not to my actual... Legendary Josh Wolf, that's me. So let's go back to the Stream Deck configuration. Which there we go. That's what we want it to be. Let's go back to this Twitter. Put a link there. Yeah, that's cool. Actually, I'm going to start the stream by having a look at the latest features in TypeScript, because TypeScript 4 is out and TypeScript 4.1 beta is out. Why am I not using it already? I need to immediately lift my game looking at the new TypeScript 4.1 features. Okay. Dun dun. Streaming live on Twitch. Yep. It's good. Push it to production. Let's press the button and see what happens. Push. Would be good if it gave some feedback. Okay. There we go. This thing's called Little Snitch, and it monitors all the network communication happening on my computer. At least the stuff that hasn't been subverted to ignore. Play this and see if it's working. Yes, it's working. Good. Okay, I'm going to ignore that for now. Move this comments and reactions thing over here on my second monitor. Very good. Okay, let's have a look at the features in TypeScript. So let's start with TypeScript version 4, which is out. Old news, August. What even is that? I mean, that's so long ago that... Okay, so new features in TypeScript 4, variadic tuple types. Variadic tuple types. Typings, yeah, okay. Okay, concatenating arrays, yeah. Well, this is interesting here. Rest elements must be last in the tuple type. TypeScript would throw an error if this was not the case. Interesting. This is interesting. T extends number. I think what this does when you put a generic like this, T extends number, is... Yes, okay. T extends array, U extends array. When you do T extends number like this, it does like a type narrowing on it. So let's make an example. So if we go file, do it in this project or do it in another project? Do it in another project. Let's open the ZB Node client because that's a TypeScript project. And as it comes up, we'll find out which version of TypeScript it's using, whether it's using the bundled version that comes with VS Code or if it's using its own version from the workspace. How do I have it set up? It would make sense for me to have it using the version from the project rather than close a few of these folders. Kind of good that it remembers the way that it was laid out previously. Oh yeah, it takes a while for the terminal to come up because this is a Python thing that grabs your current Kubernetes context. Okay, let's close these open editors. And, oh, have I got an update available? Update all the things. It's going very slow. I'm going to see if I close the YouTube music player. Downloaded a new version of the YouTube Music desktop app to see if that would speed things up, but force quit. But I think it might just be too slow. Goodbye. Quit. Ciao. And let's put some Monster Cat on instead. Now, some point in here, Pathfinder. That's real chill kind of music. And so what I can do is so I'm using Audio Hijack to get my sounds to happen. So if I say show library, I can grab an application, drop it in here, select an app, and then get the Google Chrome output. Now I can no longer hear Google Chrome myself. Loop back. What? So in loop back, this lets me know what you can hear in the stream. Maybe about that much. Advanced. Nope. Music might be a bit loud. Well, let's roll with it. And then for me to be able to hear the music, I need to go in here and add another source, Google Chrome. Now I can hear it. And I can turn it up for myself. So it can be loud for me. Okay, that's good. CPU is not peaking as much. Okay. So back to what we were doing. Start to update. So yeah, this idea here of t extends array of number. Means that it can take an array of numbers, and it'll be like as a constant, which is quite handy. So whatever you pass into it, if it can get a concrete read on what that thing is, it'll type the. It'll be best to demonstrate it. Release notes. So today's all about, this part anyway, is about all the new stuff. So there's a new release of VS Code out today, version 1.49.2. Format modified text. Limit formatting to just the text you've changed. Change casing on search and replace. Change text casing during global search and replace. Interesting. I wonder if you can do support changing regex matching groups. I don't use regex. Improved key binding diagnostics. Nah. Let's have an overview first. Filter debug console output. Okay. Improved JS debugger auto attach. Yeah, I don't use that. TypeScript optional chaining refactoring. Interesting. Convert multiple checks to a concise optional chain. That's pretty handy. Very good. If you'd like to read these release notes online, go to updates. Okay, format on save and format document commands can cause unwanted updates. Oh man, have I ever seen that? Yeah. Format modified lines command. Editor. There's a new setting, editor format on save mode. Controls of format on save formats the whole file or only modifications. Modifications file. It's going to reformat the whole thing. Yeah. How many times have you done that? You make a small change to something and submit a PR and it's like, oh, by the way, I reformatted your entire code base while I was at it. You're welcome. Okay, that's pretty cool. Map multiple selections. Okay, multi-cursor aware. Find cursor move on type control. Not sure what that does. Only show trailing white space. This is pretty cool. Numeric font weight values. Okay. Case changing in regex replace. Screencast mode customization. Oh. Wow. Keyboard overlay timeout. Change the timeout milliseconds for the keyboard shortcut overlay. I didn't even know there was a screencast mode. Amazing. Screencast mode. Look into that later. Source control repositories view. Source control providers reintroduced. Okay. Interesting. Web console filter, don't really use it. JavaScript debugger. Theme code song theme. That's cool. It'll let you know which source folder and just open index. Tell me which version of initializing JSTS language features. TypeScript version. Use VS Code's version. Use the workspace version. 402. Of course. Yep, let's use 402. And while we're at it, let's update the version in here. So dependencies, I'm on master right now. I'll branch later. So I think I can do npm upgrade TSC. TypeScript? No, TypeScript, not TSC. I might take this Kubernetes context thing off my prompt because it's too slow. npm upgrade TypeScript will go to 402. Now, while it's doing that, let's have a look at the index file. It's probably not much in here. Good. Just exports. So we'll just mess around in here. So if I make a function, hello, function, and I don't know what we'd call it, n, and then we say t extends an array of string, strigna, array of string. So it takes a parameter called p. Yeah, I've got to parameterize the function. Don't forget that. Doesn't it like about that? No, like this. Yeah. This goes in here. And then this is to type T. Actually, I think I can just do it with declare, yeah. This is how the ESFP guys do it. They just write their entire program as declared functions with type signatures. They're like implementations. It's for chumps. And then we just say it returns the same thing. So if I now do this, n const a equals n, and then I pass in an array that looks like this, a, yes, comma b. So A should be an array that looks exactly the same. Nope, it's an array of string. This is why. Like this. Maybe I have no idea what I'm talking about then. T_extend string. Let's back this. Const A. Because it's an array of string. A0. Used expression. Console.log A. Here's an array of string. Oh. Read-only any. So what's the difference then between these two functions? Function P, which takes string. So this. Call it V. And it's an array of strings. And it returns an array of strings. I thought that you'd get some kind of type narrowing here. I thought that A would come back being... Nope, it's an array of string. So what does it do then? T_extends number returns an array read-only number, and T returns something. They're generic. Table spared items are generic. So these are tuples here, so they're arrays that have two values in them. Labeled tuples. Start date, date, end date, date, period. With the addition. Birthday, date, today, date. Okay. Sometimes people get, TypeScript developers use comments. For some reason, some REST APIs return data like that, rather than return like an object, like this. A Tuesday. Unused label. This project is too strict. Const R. That. Day. They'll return something like this. Tuples, they look like this. Key value pairs. Still interested to know about what this T_extend string array does. Could I do this? Maybe this does it. Array of T_extend string. Maybe this does it. happens if I do type W equals array of, I can't I don't think I can do this. Nope. What doesn't it like about this? Someone's probably watching this. In fact, probably no one's watching this. But if someone was, there would be someone watching it going, "You're an idiot, this is obvious." Okay. See, I think if I put in R, what I get back is R. Yeah. So okay, I can do it. Let's do it without the array, like this. And then if I do const b equals p, r. So the value of b is a string, whereas the value of a is exactly r. So extends string narrows it down, so it's almost like passing in this, but it still can't figure out that that's not going to get transformed into some other value of the same type. So this extend string here says that not only is it of the same type, but it's actually of the same value. That's pretty far out. But why doesn't it work with an array? The example in here, T extends number array, T extends string array. Oh, this might do it. Can I do this? So if I now pass this in, nope, A is string. Still can't do it. Maybe if I make this read only, so that it no. Yeah, it's an array actually, so. What about this? Does this do it? It does. Okay, that's interesting. That's how you narrow it, like that. Basically what I'm saying here is this is an identity function. Okay, so it's an identity function that takes an array. Should have used rename symbol there. Okay, and then identity string would be identity string. I might write a little blog post about this because it's quite interesting for me anyway. T. T is of type T. And then here we say extend string. Well, what happens if I do this? Turns T. B equals actually, if I say identity string, but it's sufficiently generic that it could take make this read only. No, it doesn't like it. It's only permitted on array and tuple literals. Okay, because it's yeah. Let's have a look.
Now's the time. Think about all the dreams you keep inside.
Copy.
The one
Copy.
I know
Paste. Paste. Okay, so what's the value of B? It's R. Now what happens if I don't pass it in as R? It is still R. Okay, so that actually is identity as well.
That's when we need each other. That's when we need each other.
Function identity. And you pass in a constant because it knows that's a constant.
That's when we need each other. When you're falling fast,
Okay, what happens if I pass in A? Let's see what it comes back with.
closer than your heart. When
Yep, it can follow it all the way down.
the future,
Useful.
close your eyes, close your eyes. Think about all the dreams you keep inside. Think about all the ones you love. I know this beating heart will be my guide. I know
So, what happens if I make a function like this then?
when the world's so cold
Maybe identity.
I need
It takes a T,
comes and we roll.
which is an array,
That's when we need each other. That's when we need each other.
and then it has a parameter, which is a read-only. Okay.
That's when we need each other.
Read-only T? Nope.
That's when we need each other.
So here we need to say this extends an array. In which case we'd have to give a type to the array, because an array is like a generic. So I have to actually spread the values on here, like this. Yeah. T. Try this one. Maybe identity A. Value of B is R. So in that case, I don't need to spread the result on here probably. Like that. A is R, B is R. Extends any. Okay, that would just constrain it to only taking. Okay, it's definitely an identity. Where is it? Call this one identity B. Identity B comes out with R. Let's put S into here. I get back R and S, and here I get back R and S. Ends any. What happens if I do this? Comma 3. I get back RS3 number. That's funny because it can't constrain the type of the number even though it's read only. What happens if I spread this? Still just number. Okay, there must be some esoteric explanation for why, if you're extending string, you can get back this. How it knows that R and S are going to come back, but it doesn't know that 3 is going to come back? How does it not know that 3 is coming back? Let's call this identity A. So here it knows that it's going to get back. I'm going to Stack Overflow to ask this one. It's going to give me some esoteric type information from there, and I am all about that. R, S, number. Let's go to Stack Overflow. There's a TypeScript tag in Stack Overflow, and there's a community of like really passionate typing people there. TypeScript. I guess I could look around in here to see if I could figure out the answer, but I'm just going to ask the question. Ask a question. Ask a question. Code sample. Enter the code. Okay. This is in TypeScript 4. 1 4.0.1 I think 2, yeah. In TypeScript 4.0.2 compiler, is it a compiler? I think so. Type system. And infer values from the type signature. So I just say this is in the type system, can infer the values from the type signature. Infer some of the values from the type signature. In the example below. Perplexed though why it can't reason const b the value say infer. Well, I can't infer concrete value. Concrete value of the last element in const b. Anyone, can anyone explain? Explain why and how I can write a type signature. Can? Review your question. Oh, okay. Type signature. Type signature that infers all values. I guess so. It's not a very good one. Not a very good. See, I don't even know the language to describe the domain, like what the problem is. So I'm just going to go with that. Type. Types. Post your question. Is it in TypeScript? Oh, no, TypeScript. Edit. TypeScript. This is how it gets into the tags. Wow, it's been a long time since I asked a question in here. TypeScript, TypeScript, that's it. Save the edits. Okay, leaving that aside for now, let's go back here. Label tuple elements, yeah, class property inference from constructors, control flow analysis to determine the types of properties and classes where no implicit any is enabled. Okay, elaborate on this. Yep, if not area, yeah, then this square equals no area, so it would, okay, yep, it infers that. Yep, that's cool. But would not compile if no implicit any is enabled. Okay, it's because property types are only inferred from direct initializations, so their types must be either defined explicitly or using an initializer. However, TypeScript 4 can use control flow analysis of the assignments in the constructor to determine the types. Okay, short-circuiting assignment operators. Currently in JavaScript, a lot of binary operators can be combined with the assignment operator, plus equals, yeah, okay, a plus equals 1. These operators perform the operation on both operands and assign the value to the left operand. Okay. The list goes on, but with 3 exceptions. Oh, yuck. Why would you ever do this? TypeScript 4 beta would allow us to combine these 3 with the assignment, thus forming 3 new compound operators. Nah. I don't like that. We're not coding in Perl here. Unknown on catch clause bindings. Previously when we used try catch statement in TypeScript, the catch clause is always typed as any. Error handling code lacks type safety. Yeah. Try catch error. Yeah, okay. Allowed to do anything we want. Allows us to set the type of the catch variable as unknown. Yeah, okay. Custom JSX factories. Okay, not doing anything with React at the moment. Notable mentions. Okay, so that was TypeScript 4. Now let's have a look at TypeScript 4.1, the new hotness, which came out like a week ago. What am I even doing? 4.1 beta. Okay, npm install TypeScript at beta. Don't do it. Don't do it. Template literal types. String literal types in JavaScript allow us to model functions and APIs that expect a specific set of specific strings. Okay, so this is like for actions in Redux. Yep. Okay, didn't work. That's pretty nice. String literal types catch basic spell checks. Yep. String literals can be used as property names in map types. We also like that string literals can be used as property names in mapped types. In this sense, they're also usable as building blocks. Really? Okay. Okay. Building other string literals. Oh my goodness. What happens when you have unions and substitution positions? Oh man, okay, now this type system is going to start to get crazy. Crazy. This is what I mean with these FPTS guys. They write their whole program in the type system and then they're like, implementation. That's just like an afterthought. You know where I could use this actually is in, let's open, Open. Okay, new window. No, wrong thing. This one. File. New window. Open recent. Stats crawler. Move it over here in case it opens up. Shouldn't do. With some kind of secrets or something. Oh, very good. Stats crawler. Okay, so in here actually, I could use it in here.
Is this a fatal attraction?
Where would I use it in here? So if I go into the app itself, okay, I have these actor types. So I overloaded this concept of the actor names, which are an enum. There's also double as the config keys in the config file. So when I require the config and I get this object in, which is of type any. If I go into where that comes in, no, actually, it's in this file. CPU chugging away. Okay, so let's go back to app.
Been having these conversations.
So where do we get the stats query from?
More than just undercovers. I can't forget you.
Dun, dun, stats query here.
What's on your mind?
How does it know that?
Used to be perfect strangers. Maybe I fell for you.
How does it know that?
Nothing major. Just trying to speak the truth.
Config template? Oh, it must be reading the concrete shape of this JSON file. Okay.
Gonna do with us.
Okay, the machinery I've wrapped around it is generic until it gets down to... Yeah, okay. When you're using these actors, you've got to write these JSON schemas. How would I use it to do that? Well, let's just try it. So if I say type config equals, and then pay for key in actor. Let's see if it can do this. Okay.
Used to be perfect strangers. Maybe I fell for you.
Okay.
Maybe it's nothing major. Just trying to speak the truth.
And then I think I can do this. Type RT equals key of config. Equals actor. Goes backwards. Key of. Okay, interesting. Yeah, I'm not going to use it in there. But that was an interesting diversion. Back to the new features. Building other string literal types. Okay. Union types. Amazing. Now we're starting to get into like another level of abstraction. They're going to go to type classes for sure. For example, you could write about manually, sure. 9, we need a ton of them, automatically generating them, or just use string. Some of the real value comes from dynamically generating new string literals. Takes an object, produces a mostly identical object with a new on method to detect for changes to the properties. Watched object. Listens to the event first name changed. We'll type this. Okay. Ooh. this is interesting here because this is how you can make event. I use this in the Node client. We can get rid of that. It's documented in Stack Overflow now. Inside the Node client, in the gRPC client itself, we are listening to these things here. Stream any, on any. Yeah, I've typed these here. Okay. This example here is interesting to me. Make watched object takes an object of type T, returns T, and okay, the merging of T and prop event source, which is string and key of T. String and key of T. Did you not just do $key of T? Templated strings and types. We can also do something special in template literal types. We can infer from substitution positions. We can make our last example generic to infer from parts of the event name string to figure out the associated property. Okay. Here's that narrowing I was pointing to before. Not just string, but the specific string and key of T.
Sounds quite interesting. Is this a space flute?
Okay.
Galactic trumpet.
Wow. Okay. Okay, that's pretty far up. Few new utilities for modifying casing and letters, converting lowercase and uppercase characters. Uppercase, lowercase, capitalized and uncapitalized. I mean, if you're writing code, application code, this is a little bit overkill. When you're writing libraries that other developers are going to consume, then it makes sense. Especially if you write a library that can wrap generic objects and things that the users create. I mean, I use that kind of generics approach in here. Where would be a good example? Like, where you can create a ZB worker in it, like.
Galactic trumpet.
Yeah, can take a shape of their variables, custom header shape, worker output variables, because in this case you're getting payloads that are coming from ZB as variables. They're key value pairs and you don't know what the shape of them is going to be, but the application programmer might have a strong JSON schema for it, which they can then pass into these functions, and then they'll get IntelliSense at design time. The variable payloads, that's very handy. Modifying the string literal, okay, upper, lowercase, capitalize and uncapitalize, okay. Original pull request. The in progress pull request to switch to type alias helpers. That's interesting. Let's have a look at that. Key remapping and map types. Just as a refresher, so this like 4.1 looks like it's just full on generic typing stuff. Map type can create new object types based on arbitrary keys. Okay. Yep. New object types based on other object types. Partial. Yep. Until now, map types could not produce new object types with keys that you provided them. Create new keys or filter out keys based on the inputs. Remap keys and map types with a new as clause. This is the new syntax. Key of this T type that comes in as a new key type. Okay. It is.
Now the sun gone down, lights in the distance, a forgotten day.
This will be handy. You can even filter out keys by producing never.
Stand on the edge of the world.
Exclude K kind. Recursive conditional types. Functions that can flatten and build up container types at arbitrary levels. The then method on the promise, then method on instances of promise. Unwraps each promise until it finds a value that's not promise-like and passes that value to a callback. It's a relatively new flat method on arrays that can take a depth of how deep to flatten. I didn't know that. Expressing this in TypeScript's type system was, for all practical intents and purposes, not possible. While there were hacks to achieve this, the types ended up looking very unreasonable. These are some restrictions on conditional types. They model these patterns, they immediately reference themselves within their branches, making it easier to write recursive type aliases. Okay, that's pretty cool. Number. Element type, U. Okay. Deep flatten. Okay, rather than using declare, they use like a throw, an actual concrete implementation with a throw in it. Similarly, in TypeScript 4.1, we can write an awaited property to deeply unwrap promises. Really? Wow. Increased type checking time. Okay, so yeah, they're getting to the point of being able to do actual computation in the type system. Pile time error recursion depth, okay. Pedantic signature, index signature checks. Okay, yep. No unchecked indexed access. Extra properties, okay. Okay. Every property access potentially undefined. Okay. Oh, yeah, okay, so you have to get some type safety on it. You have to say YOLO. Okay. Indexing into an array is also more strictly checked. What? Don't need the indexes. How could this be possibly undefined? Can you have an undefined element, undefined as an element in an array of strings? Don't need the indexes. Okay. It's base URL. Check.js implies allow.js. X17 JSX factories. No, I haven't been using that. Editor support for the JS.doc.c tag. Okay, for cross-linking. That's cool. Breaking changes. Abstract members can't be marked async. Callers are only concerned with the return type. Yeah, sure. Yeah, makes sense. Any unknown are propagated in falsy positions. Previously, for an expression like foo and something else, the type of foo was any or Unknown. The type of the whole expression would be the type of something else. Well, it could be unknown.
The most bizarre and brutal.
For example, previously the type for X here was sum prop string. That's wrong. Since nothing is known about the type on the left side of the AND, we propagate any and unknown outward instead of the type on the right side. Yeah, sure. Turn X. Yeah, okay, if that's false. But yeah, it could be anything. So it should be any. Oh, okay, this is interesting. That's good to know. I would usually use a ternary condition actually instead of doing that. Otherwise, declaration out file requires a package name root. Post-processing, okay. Resolves parameters are no longer optional in promises. What? Okay, this is definitely a breaking change. Resolve no longer has an optional parameter. It must be passed a value. Often captures legitimate fix past the correct argument, explicit type argument. Something async value. Oh yeah, okay, so you can do a promise void. Okay, that's cool. To help fix this break.
Crime and violence.
Okay, I'm not going to remember any of this until I run into something and go, I think I read about that somewhere. Okay, I'm now up to date with TypeScript 4.1. Is there anything in here that I just like really need? Recursive conditional types, no. This kind of advanced typing here, key remapping, maybe. These string literal types, yeah. I'll probably run across an idea where I'm like, I could use that here. And these breaking changes, I'll run into those once I upgrade to it, which is not going to happen anytime soon. I'll wait till it comes out stable before I try doing that. Okay, now up to date on TypeScript, so I can go back to actually working on the ZB Node client. There's a memory leak in there that I need to fix. I'm also running it in a new production system that I just deployed into Google Cloud, which scrapes metrics from the internet once a month. So it's going to just run continuously for a month, and if it runs out of memory during that month, it won't run on time. So I'm invested in making sure that this thing is running lean and correctly. Okay, stay human, protect the planet, raise the consciousness.